Welcome to class, students. In this class we are going to discuss functions, few more examples. In the first example, left or right shifter. To illustrate how range for the output value of a function can be specified, let us consider a function that shifts a 32-bit value to the left or right by 1 bit based on a control signal. Define a module that contains function shift. So we are writing module with a name shifter. So this is a partial code, so complete block we are not writing. So this is indicated by dots here. Left shift we are defined as with value 0, right shift with value 1. Register 31 down to 0. So address is 32-bit, left address is 32-bit, right address is 32-bit. So shifted value, left shifted value is stored in left underscore address, right shifted value is stored in right address. Always whenever there is a change in value of address, you have to perform left shift by one location, right shift by one location using function shift. Function name is shift. You are calling function here for left shift and right shift. We'll see how the function is implemented. So this is the declaration part and function call we are doing here. Left address equal to shift, right address equal to shift. We are calling this function. If you see an example, here of a function shift, how they are written. The function shift will return 32-bit here, so 31 down to 0. Name of the function is shift, and then input address, you are sending two parameters in function. One is address and another one is left shift or right shift bit, that is 0 or 1. So address and the control signal. Now within the function, so function name is shift, shift is assigned with, and this value is going to return wherever the function is called. If I assume first case where left address is equal to shift address left shift value is what? 0. Address we have to assume say here left shift is 1, so you are called left address equal to shift address left shift. Say suppose this function is called. In this case you have to assume an address, say address, say 32-bit in size, 32 bits, say all bits are 8 bits, 12, 16, 24, 32. So total 32-bit data we have written. Suppose this is a input data given through address and control signal. Okay, it is left shift. That control signal is value is what? This control signal value is 0, because left shift value is 0 and address is mentioned here. This is a 32-bit value. In that case, what happens? Control 0 is compared with left shift value, and this condition becomes, we are using conditional operator here. It contains 3 expressions. First expression is a condition, then second expression, third expression. Second expression is evaluated when condition is true. So 0 equal to 0, the condition is true. In that case, address is shifted left by one location. So shifted left by one location means, so you will get 3 zeros. This data will vanish, remaining data, so this data will be there, and shifted location will get 0. This is a new data that is stored in shift, and in turn this value is returned and it is stored in left address. In turn this is stored in left address. Similarly, if you see right address, so right shift, this value is what? 1. We have defined it as 1. Assuming previous example only, address size is 32-bit. In that case, so the function is right address, you are calling same function shift, you are spending address and right shift. So here address, if I assume same as so lower 8 bits I'll write. So total, say suppose 32 bits we have written. When right shift is performed, this bit will vanish. This will be your new data. Shifted location, here you will add shifted location, you add 0. This is a new data that you are storing as part of shift. So new data will be 5 zeros, then 4 ones, 4 zeros, 3 ones. This new data is stored in shift. In turn it is wherever function is called, it is stored back in right address. So left shift and right shift is performed. See here what is the condition? Control signal we are passing as 1 for right shift. Control signal we are passing as 1 because right shift value is 1 tick B1. So 1 value we are passing, 1 we are comparing with 0, condition becomes false. So this third expression is evaluated. Third expression means the address, 32-bit address, it should be shifted by one location towards right. Towards right means LSB bit will vanish. So this is a new data. In shifted location you will get additional 0 added, this 32-bit, and the shifted value is stored in right address. So left shift and right shift is controlled by using values given in function. Automatic or recursive functions. Functions are normally used non-recursively. If a function is called concurrently from two locations, the results are non-deterministic because both calls operate on the same variable space. However, the keyword automatic can be used to declare a recursive function where all function declarations are allocated dynamically for each recursive calls. Each call to an automatic function operates in an independent variable space. Automatic function items cannot be accessed by hierarchical references. Automatic functions can be invoked through the use of their hierarchical name. So one is function is called concurrently from two locations, results are non-deterministic, means erroneous. Both calls operate on the same variable space. But the keyword automatic can be used to declare recursive function where all function declarations are allocated dynamically for each recursive calls. We will see one example, factorial example. You can observe recursive automatic function. In this example, module top, so function you can observe here, function declaration part with the keyword automatic integer factorial. So function name is factorial. It is recursive type because we have used keyword automatic. Input size is 32-bit. Input size is 32-bit. Integer I. If operator, so the operand that we are using here is OPER. So OPER operand, for operand we are using this notation. If operand is greater than or equal to 2, then perform this operation. Say suppose in this example factorial of 4 you are calculating, factorial of 4. We'll see result factorial of 4. Function call is done here and the value need to be assigned to result. So what happens is when factorial 4 is called within this function 4, and then it will be factorial 3. If we are calling factorial 4, but in turn it is converted as 4 into factorial of 3. This factorial of 3 in turn it will call same function again. Here it will be 4 into 3 into factorial of 2. Then 2 into factorial of 1. So factorial of 1. When operand value is less than 2, in that case this particular function returns 1. So 1 into 2 into 3 into 4, that is 4 into 3 12 24. This particular function will return value 24, and that we are displaying or printing with the help of display command. Factorial of 4 is %0d, that is nothing but a %d or %0d. Okay, %d is sufficient. We can write %d. Result it will display in decimal and the value is 24. So this is how a recursive function works in Verilog. What I'll summarize once again. If you observe, if you are sending factorial of 4, this is a function call, you need to calculate factorial of 4. So first time when function is called, so it will check operand is greater than or equal to 4. So it will perform what? Operand value is 4, then factorial of 4 minus 1, that is 3, factorial of 3. Now function execution won't stop here. So within the function you are calling once again that same function. So it will repeat. Now it will check new value. So here you are passing 3. So 3 means again it will perform factorial of 3 minus 1 into operand, that is factorial of 2 into 3. It won't stop. Again one more time you are calling function. So it will enter, so one more function, recursive function. So whenever it encounters, here also there is a function call. So it repetitively calling the same function. So factorial of 2, when the value is equal to 2, again it performs 2 into 2 minus 1, factorial of 2 minus 1, that is factorial of 1. So again it calls same function. When operand is less than 2, in that case it will return value 1. So finally you will get 4, 3, 2, 1. You need to multiply. So by recursion, so final multiplication result you will get it as 24 in this example. Okay students, thank you. We will conclude today's class. The 4th module is over. In next class we begin with 5th module, logic synthesis in Verilog.